2,2-dimethylpentane. Let's draw its structure, and it's nice that the IUPAC system is based on its structure. So all I have to do is read this and understand what it means, and I have a structure. So let's do that. So the first thing I look at is the parent chain, pentane. This is the longest continuous chain of carbons. And pent means 5 carbons. And if I don't know, I go here. Table P says pent is 5 carbons. And the ane in table Q tells me I'm dealing with an alkane, which is a single bonded hydrocarbon between the carbons. So we start with a 5 carbon chain. 1, 2, 3, 4, and 5. I'm going to put single bonds in between them because that is what the ane means. It's an alkane. The pent is the 5 carbons. Okay, now what's attaching to this parent chain? It looks like I have a dimethyl, which is 2 of the same type, and a methyl group is a 1 carbon group. This attaches to the chain, which is right here. And of course, carbons must make 4 bonds, so it's going to make what? It's going to fill itself up with the hydrogens, so sometimes we call it a CH3 group. And we write a line saying it's attaching to some kind of chain. So we have 2 of them. Now I know that because of the di, and I know that because every single number tells me where they go. So the first thing I'm going to do is decide where my second carbon is, because they have to go on a particular carbon. And because they're 2, 2, they're saying I'm on the same carbon. So when I count, if I make this my first, my second, my third, and my fourth, and my fifth carbon, this is my second carbon. And so I have a methyl group on the second, CH3, and I have another one on the second group, CH3. And I'm done. The 2, 2 says they're both on the second. And it's only, if you notice, room for 2. So I could never have 2, 2, 2. You notice I'm already bonding to the first carbon and to the third, so there's no room. So this is my 1-methyl. Here's my second. This, of course, is my chain. And now all I'm going to do is fill in the rest with hydrogens so that every single carbon has 4 bonds. So the filler is kind of like the hydrogen. This carbon already has 1, 2, 3, 4, so it's no good, but this one has what? Needs to have 2. This one needs to have 2. And this one needs to have 2 as well. And the ending, the terminal one, just like the terminal end of this carbon has to have 3. Okay, if you leave out any of these H's or these dashes, it'll be wrong. And there's your structure. Okay. Again, another example of a saturated hydrocarbon, but a branch type. Notice you say we have 1, 2, 3, 4, 5, 6, 7 carbons, but we're only considering what? These as the numbers to count. This is the longest continuous chain. Now I could count this as 1, 2, 3, 4, 5. So if this is my longest continuous chain, all right, we would have the other 2. So this longest continuous chain is my 5, and these are my 2 attaching. If I was to make it another way, if this was my longest continuous chain, right, if this was 1, 2, 3, 4, 5, these 2 would be my methyl groups. It doesn't really matter how you count, but the bottom line is the longest continuous chain of carbons, and then that's going to be your parent name, and then you have the attaching.